Hello everyone. In this lecture we are going to understand game theory. So the name is quite interesting. It should generate the curiosity in the mind that what kind of games we'll be actually studying or looking at in this topic. So let's begin. So let me make it very clear. Here we are not going to talk about any those kind of games like computer games, indoor games or outdoor games. It has nothing to do with that. While game here comes under a very broader definition. So this concept game theory is one of the branches of decision making, which is a very popular area in operations management or in operations research, you can say. So here I am giving you a very precise meaning of game theory, that what actually we are going to look at here. Game theory deals with decision situations. So as just explained you that it comes under the category of decision making problems in which two intelligent opponents with conflicting objectives are trying to outdo one another. So let's understand the meaning of each and every term here one by one. So two means there will be two players involved, two opponents involved. We will not be looking at those games right now where the number of players is more than 2. So that's fixed. Intelligent opponents. So to understand the meaning of intelligent opponents, firstly we need to understand the meaning of opponents. So it's clear that opponents are competitors or the persons who are playing against one another. So there are two business competitors in the market. Both of them have created their product. They want to sell it with a higher profit. So they are competing against each other. They are doing something to attract the market value, to attract the audience towards them. So whatever. So opponent word is those two teams, those two persons or players who are competing against each other. And the meaning of word intelligent here is that it is assumed that each of the opponent will play rationally, intelligently and logically. So let's elaborate it more. For example, there are two players involved. Say one of the player is A, one of the player is B. Suppose the player A knows that if I choose my first strategy, let's call my first strategy A1. I'll get in detail with this the meaning of the word strategy later, but let's just understand it here like that. That if A uses strategy A1, then say B gets a profit of $10, and if A uses strategy A2, then say B gets a profit of $5. A is having this information. So A is going to take a wise decision of choosing the strategy A2 because in this case his opponent is getting least profit. Out of these numbers 10 and 5 is the minimum. So that's why A is going to make this decision. So that's the meaning of intelligent, that both the players will be playing rationally, logically and intelligently. They will not forcefully make those kind of moves or not mistakenly choosing the wrong strategies. So it is assumed both of the parties, both of the opponents are intelligent enough to play fair. And then let's understand what is the meaning of this conflicting objectives. So I hope that's clear already. Obviously both the players have different objectives. Player A wants A to win, player B wants B to win. So their objectives cannot be same, they are exactly opposite of each other. So they are conflicting objectives and obviously they are trying to outdo one another. So that's a precise contextual definition of game theory. Otherwise we don't need to remember this definition as such. Rather we just need to understand the meaning of the terms involved here. So to have some examples of game, we can have the example of launching advertising. For example, there is a company in the market, they want to sell their new product, so they want to advertise it first. So they will make for certain strategies that whether we should advertise on social media, whether we should advertise on television or in newspaper or anything like that. So there will be some strategies involved and based upon some data they will choose their strategy. So that's the example where game theory will play a role in making a decision. And similarly, there can be other example, campaigns for competing products. There are plenty of more examples you can find in books. It has many more applications. So if you talk about the applications, I have few to mention here: evolutionary biology, economics, business management. I've just given you the example of business management. Two parties are competing against each other. Decision making, psychology. So it really depends upon the context of each and individual subject, what kind of problems are involved there and how they take the form of similar problems as we are going to study in game theory. But it really has a lot more applications. So that's all about the motivation why we want to study game theory. So now let's begin with the mathematical part. So I have few definitions here. So players, I have already told you, there will be two competing opponents. Strategies, both the players will have their own set of strategies. Just the way right now I gave you the example that one of the company wants to advertise in social media, other company wants to advertise on radio and television. So that is kind of an example of a strategy chosen by the player. Payoff. Now these games are not played for free. There is always a payoff, there is always a reward associated with each payoff, each strategy. For example, if a company or if a player, or you can use the word opponent or competitor, if one of the competitor chooses to advertise on television, then there will be a certain payoff involved, that if he advertises in television, then this much profit he is going to get and the other person is going to lose this much. So there is always a payoff, or it can be in the form of money, it can be in the form of some value in the company, it can be a value of their stocks. So whatever it can be, there's some kind of payoff involved in that, which one player receives from the other. And it's a zero-sum game. So what's the meaning of zero-sum game? It means that gain by one player equals the loss of other players. So that means there is no third kind of person involved there. So if I say that on making a particular move, A gains $10, so that means with the same move, B loses $10. So whatever is the gain of one person is a loss of other person. So that's the meaning of zero-sum game, that the sum of gains and losses equals to 0, because whatever is gained by one is equally lost by the next person. So the kind of games we will be dealing with: two-person zero-sum game. Two-person I've already explained, the number of players is going to be exactly 2, and it's a zero-sum game. So now let's talk about the matrix representation of game, that whatever kind of data we are given, we have to put it in the form of a matrix so that we can do with the further mathematical calculations and techniques. But let's first learn what is the meaning of this matrix representation, what is the notation depicting here. So player A is usually represented by the rows and player B is usually associated with the columns. So it's not any fixed thing, it may be changed, the order may be changed, and the name of the player also does not matter, whichsoever you want to call A and B. So just by convention, it's always player A is this side and player B is this side. Anyways, that does not matter even if you find that changed in some particular example. So here I have given you an example of a 4x5 game. 4x5 is actually depicting the size of the matrix. So there are 4 rows and 5 columns. So therefore this is a 4x5 game. So player A has 4 strategies. These are the strategies of player A: A1, A2, A3, A4, and there are 5 strategies associated with player B: B1, B2, B3, B4, B5. So actually what these strategies physically representing, that really depends upon problem to problem, that varies from problem to problem. But here to understand, you can just say these are the individual strategies of each player. And then what else is given to us? Payoffs. Just now I explained you the meaning of payoff, that with each strategy there is an associated payoff, that say this number A11 is denoting the amount of money which A is going to get if A plays with strategy A1 and B plays with strategy B1. So there is a payoff involved, A11. So remember, this is the payoff matrix of player A is always given. You are never given payoff matrix of player B, or you can say you are always given the payoff matrix of one of the players. Why that is so? Because the other is not required, because it's a zero-sum game. whatever is gained by one of the player is lost by the other. So you don't need to know actually what is the payoff of the other person. So it's just the negative of the payoff of the this person. For example, if this number say is -3, so that means if A chooses strategy A2, B chooses strategy B2, then A gets -3, or you can say B gets 3, whatever it is, dollar, rupees, and A loses 3. So it's actually the sign which determines that which player is gaining it and which player is losing it. So it's always with respect to one player, and it's in most of the example it's always with respect to player A. So the payoffs are given with respect to player A. So these are always given to us. Now we want to find a optimal solution of the game. So before telling you the technique that how to find optimal solution of the game, we should be clear with this meaning what we are actually looking for in the game. So if you pause this video and ask this question to yourself, that when a game is being played in front of you, two players are playing, then what is the outcome of the game? When you will say the game has reached a decision. So the game is going to reach a decision if you declare one of the person as a winner and the other a loser. So the first thing we are looking for is who wins the game. That's the first question. And then we are looking for by which particular strategy that person has won the game, and by which particular strategy the other person has lost the game. So the who wins the game, what are the strategies involved, this question we are looking for an answer. And the third thing we are looking for, what is the value of the game. Value of the game is the final payoff. I didn't define it formally here, but value of game means that suppose A wins, then what is the actual reward, what is the actual payoff he is going to get. So that's the value of the game. So we are always looking for this data, and whenever someone asks you solve the game, so that means these questions are asked to you. So let's understand this through an example, because there is not much theory involved, so I am not giving you any sort of theoretical calculation. So whatever the technique, whatever the solution technique is available, I will be directly explaining on the example only. So we have two companies A and B which sell two brands of flu medicine, so whatever they are selling. So the company A advertises in radio, they are calling it strategy A1, television, they are calling it strategy A2, newspaper A3. Similarly, company B, in addition to using radio, television and newspaper, also mails brochure. So that means A is having 3 strategies, A1, A2, A3. B is having 4 strategies, B1, B2, B3 and B4. Depending upon the effectiveness of each advertising campaign, one company can capture a portion of the market from the other, and the following metric summarizes a percentage of market captured or lost by company A. So this is nothing but they are saying you are given the payoff metrics of company A. So payoff is here the percentage of the market capture. So that doesn't matter whatever is the payoff representing, it varies from problem to problem. We are actually just concerned with the mathematical numbers here. Okay, so now we want to determine a solution to this. The matrix is already given to us, we want to determine a solution to it. So the first step is you find Maximin. So we need to understand it very carefully that what is the meaning of this Maximin. The technical meaning is it's broken into two parts, Maxi-min. So firstly you compute certain minimas, then out of those minimas you choose the maximum one. So that's called Maximin. But why we are computing this and why it is required here? So for that to understand, let's go to this particular example. So suppose A chooses strategy A1. Now we are looking at the problem just from the perspective of player A, as if we are player A and we are playing the game. So suppose you chooses strategy A1. Then you do not know which strategy B is going to choose, but you do have the information that if B chooses B1 strategy, then I am going to get, the player A is going to get a payoff of 8. So this is a percentage of the market captured. So that means if A chooses to advertise in radio, so A1 strategy is advertising in radio, and then he is thinking that if B also chooses to advertise in radio, then definitely I am going to capture the 8% of the market share. If B chooses to advertise in television, then I am going to lose 2% of the market share. If B chooses to advertise in newspaper, then I am going to gain 9% of the market share. And if B mails the brochures, then definitely I am going to lose 3% of the market share. So A does not know which strategy is going to be chosen by B, but A has the information that if I choose this strategy, then what are my various possible outcomes depending upon what strategy is chosen by player B. So based on this information, A has to make the decision. So what A will try to do, A will try to find the worst case possible for him. Like whatever B chooses, whatever worst can happen to player A if he chooses A1, that at least he is going to get the reward or the payoff -3. Means the worst which can happen with player A if he chooses strategy A1 is that he is going to lose 3% of the market share. So A is just trying to play safe. He is trying to look at the options which are going to give him an idea about what is the worst situation which can happen with him, because that's how we play in real life. We do not know what move the other person is going to make, but to make our final decision, we always tend to think like that, okay, what will happen even if the worst case scenario occurs. So A is trying to estimate his worst possible solution, the worst possible payoff he can get depending upon what strategy B is choosing. So that's why we compute the minimums here. So the first entry -3 is the minimum of first row. Similarly, you think about the second strategy. Now A thinks that if I apply strategy A2, then depending upon what strategy is chosen by B1, B2, B3 or B4, what strategy is chosen by player B, these are my respective payoffs. So here also he computes his worst possible payoff, that whatever happens, whatever strategy B chooses, I am definitely going to get at least 5% of the market capture if I choose strategy A2. So corresponding to strategy A2, corresponding to second row, the minimum is turning out to be 5. And similarly, you compute the row minima of third row, which is -9. So these are the minimas. So these are representing the worst possible scenarios for player A. Now A wants to make his decision whether he has to play with A1 strategy, A2 or A3. That means whether he wants to advertise in radio, television or newspaper. So definitely he is going to advertise with television, means he is going to choose the strategy A2, because out of these three worst possible situation, the best one is this one. So this is called choosing best of the worst. So remember, this logic, this principle applies in game theory while making decisions best of the worst, that you compute your best ever possibilities, and out of those worst possibilities you pick up the one which is giving you the best answer. So best of the worst is also called the maximums of the minimums. So out of these row minima, you compute the maximum value, which is called Maximin. So this is the physical meaning of the word Maximin. Although mathematically it's very easy to find, you just need to compute row minimas and then choose the maximum, call it Maximin. Now let's do the similar thing for B. So if B is going to play with strategy B1, then B is going to think that whatever A does, whatever strategy A chooses, I am definitely going to get. So the worst case of B here is not going to be given by the minimum of these, but the worst for B, because strategy is still the same, underlying principle is still the same, best of the worst. So I am trying to figure out the worst possible scenario for B here if B chooses B1. So the worst possible payoff for B is going to be given by the maximum here instead of the minimum. Why so? Because this matrix is giving you the payoffs of player A, not of player B. So this 8% market share is the best for A, means out of 8, 6 and minus 2, so 8 is the maximum value, but this is actually the loss of B if B chooses strategy B1. So that means if B chooses B1, then, and if A chooses A1, so B is going to lose 8% of the market share. If A chooses A2, B is going to lose 6% of the market share, and if A chooses A3, B is going to gain 2% of the market share. So out of these, the maximum loss which can occur to B is this. So that's why this time I'll be computing column maxima. So you remember always this. For player A, for that player whose payoff matrix is given, for that you have to compute Maximin, and for the other player you have to compute Minimax. So for rows you compute the Maximin, you compute the row minima and then choose the maximum, while for columns you have to compute the column maxima and then you compute the Minimax. So that's why this is called Minimax. So out of 8, 5, 9, 8, so you can see in the second column the maximum was 5, in the third column maximum was 9, in the last column the maximum was 8. So 5 is the minimum of these maximums, so this is Minimax. So this is the situation we are getting when Maximin is equal to Minimax. So we call such a situation a saddle point. It's also called equilibrium. The game has reached an equilibrium. The game is having a saddle point if Maximin is turned out to be equals to Minimax, because they are occurring here. This Maximin was coming from this 5. This Minimax is also coming from this 5. So that means the final decision is A will choose A2, B will choose B2, because this is satisfying both the players. A was trying to maximize his minimum losses and B was trying to minimize his maximum losses. So therefore this is the common value which we are getting, and that's the optimal solution. So we got the answer we were looking for. Value of game is 5. So value of game is the final payoff which the winning player gets. So whatever is this Maximin equals to Minimax value comes, that is the value of the game. You just have to write like that. Who wins? So this depends upon this. If value turns out to be positive, that means A wins the game. If value turns out to be negative, so A loses it, because the value is the payoff of player A. So if it is positive, that means player A is gaining something, so that means it is winning. But if it is negative, then player A is losing and player B is winning. So it depends upon the sign of the value of the game. So here value of the game is positive, so A is winning. And how much A is winning? 5%, because you remember, if you look at the statement of the question, these payoffs are representing the market share. So A wins 5% of the market share. A chooses A2, B chooses B2. So that's a pure strategy solution. Pure strategy solutions means out of the given strategies, very deterministically you can tell, okay, yes, definitely A is going to advertise in television and definitely B is also going to advertise in television. So, and by choosing these strategies, A is going to win 5% of the market share. So that's the answer and that's the interpretation. So obviously now the question naturally comes in our mind that what will happen if Minimax is not equal to Maximin. So to understand that situation, let's have a look at this example. So in this example, we are given two players who are playing the coin tossing game. Each player, unbeknownst to the other, chooses a head or a tail. Both the players would reveal their choices simultaneously. If they match, then the player A receives $1 from B, and if they do not match, then A pays B $1. Formulate the payoff matrix for player A. So this is a different example here. In this, we are not given the matrix. In the previous case, in the previous example, we were directly given the payoff matrix, but here we are asked to first formulate the payoff matrix. So this can also be asked. So by reading the statement of the question, we have to formulate the payoff matrix. So it's very easy. So there are two strategies for both the players. Either A gets a head or A gets a tail, B gets a head or B gets a tail. So if they match, so that means head, head. So that means this particular payoff and tail. That means this particular payoff is $1 because A is receiving $1. So this is 1 and otherwise A is going to pay B $1. So that means for other two cases this is -1 because here it is not matching head, tail, tail and head. So it's -1. So that's a formulation of payoff matrix is done, and now we have to proceed usually as we proceeded in the previous question. So the first step is we have to find a row minima. So row minima in this case is -1, and then the maximum of those minimas is -1. Both of them are same, so whichever you call maximin does not matter. So I am calling this one maximin. And then column maxima, both the column maxima are 1 and the minimum of them is 1. So whichever you call minimax. So you can clearly see maximin is not equal to minimax here. So that means no pure strategy solution exists. So that means at this point I cannot tell which strategy to be chosen by player A and which strategy to be chosen by player B. So that means I cannot tell a solution, I cannot declare a solution at this point of time. So therefore we need some other technique here at this point for these kind of cases which will give me the optimal solution. That is called mixed strategy solution, and we'll take up that case in the next lecture.